Hey guys, so let's discuss new round, which is round 9. Microsoft interview loop round 9, which is called architecture round. And here the question is given to you is design a global payment platform. Okay, so let's say what will be the functional requirement and what would be the non-functional requirement. After that, we will seeing the answer based on three roles: software engineer, senior software engineer, and architect. Okay, so see, if someone will ask you to design global payment platform, okay, so what would be the functional requirement expected there? Okay, the platform should support what it should support. It should support payment authorization, payment capture, okay, then refunds, payment status tracking, multiple payment methods, currency conversion, and fraud detection, retry failed payments, audit logs, and notifications. Okay, and what would be the non-functional requirement here? So this will be common for all, right? So like high availability, 99.99%, low latency, strong durability, global deployment, because this is a global payment system, right? And then PCI-DSS. So what is PCI-DSS? It is payment card industry data security standard compliance. After that, fault tolerance, and then multi-region support, scalability, and observability. So all these things should be there. Now, software engineer, what he will be answering for this 2 to 5 years of experience if we ask him to design this kind of system. So his expected answer would be that I would be design the payment platform using microservices, right? Each service has a single responsibility such as payment processing, fraud detection, notification, and currency conversion. Now, communication between services would be asynchronous wherever possible. So he said two things, that first of all, he will create a microservice. Okay, so he will segregate the responsibilities in different services. Okay, and second, he will be using asynchronous communication. He will be using the messaging queue. So the architecture, high level architecture for him would be something like this: customer will send request to API gateway, and from there it will go to different services like authentication, payment, fraud, currency, and notification, different services. Then it will go to Kafka, and then from there it is going to database. Okay, now core APIs, he will be using payment post, okay, to create a payment, then get payment of the particular ID. After that, payment ID capture, okay, which is again post, payment ID refund, or payment ID status. Okay, this one will be post and this one will be get. Okay, so senior software engineer, what he will be saying, 6 to 12 years of experience. The expected answer would be I would separate the payment platform into independent microservice communication through Kafka. So again here he is also saying the same thing. And then payment processing should remain highly available while supporting retries, idempotency, asynchronous workflows for downstream systems. Okay, means see what is important here: payment system, payment service, right? For example, if you are making a e-shopping cart, so there e-shopping application, so there the order creation is important, order place the order, that thing is important, right? And notification and all those things will come later. So here also making payment is an important thing, and also it should support like retries, idempotency, or synchronous workflow for the downstream systems. Now, production architecture, if you see, so like client request will go to API gateway, from there it will go to again different services, and then through Kafka it will go to SQL or Redis, the same architecture. Okay, now design goal here would be exactly once. Payment processing exactly once means payment should be processed once only. Okay, idempotency, now independent scaling, event driven communication, fault tolerance, compliance, and low latency. Okay, tomorrow if I need to add one more service, I can add here. I don't need to disturb the existing system. Right now, principals engineer or architect who have 12 plus years of experience, so he would expected to answer for this is, I would design the payment platform as a globally distributed event driven architecture. Now here he is talking about global things. Okay, globally distributed event driven architecture with strong consistency for financial transactions, because here you are doing financial transaction. Eventual consistency will not work here. A strong consistency should be there. Now, asynchronous integration for downstream services, multi-region deployment, PCI compliant security, and AI-driven fraud detection. So now enterprise architecture will be something like this. Global user will go to Azure front door. It is like a load balancer. Okay, he's responsible for he's a global entry point. He's responsible for CDN, then web application firewall, and DDoS protection. Okay, rate limiting and all would be here. Then after that, not rate limiting, DDoS protection would be here. Then you will have a API gateway. API gateway is responsible for routing the request, rate limiting, authentication, request response transformation. Okay, now from there it will again further go to different services, because we will be using here microservices. Okay, so you will have a authentication service, payment orchestrator, fraud detection, ledger. Okay, because this is a payment system, so ledger, you need to record the transaction, okay, and balance. Now currency conversion, settlement, notification, and audit, right? So then after that request will go to Kafka, and from Kafka it will go to Redis, distributed SQL, object storage, and then AI platform. Okay, so like AWS or something you will be using for object storage. Here you will use Azure's object storage, okay, because you are giving interview for the Microsoft. So okay, guiding principle is strong consistency for payment. Okay, that is for sure. Then event driven workflow, global resiliency, compliance, cost efficiency, and complete observability. Okay, now let's talk about 5 follow-up questions. So the first one is idempotency. What is idempotency? Software engineer will say that payment API must support idempotency, so repeated request caused by retries do not create duplicate payment. Okay, one request is let's say one request is there which is deducting 1000 rupees from my account. Again you have a duplicate request. Again that duplicate request should not again deduct 1000 rupees from my account, right? He should know that this is a duplicate request, so just give the response what was stored for the first API, like 100,000 rupees deducted from this account, something like this. Okay, senior software engineer will say that he will store idempotency key, payment ID, and responses. Okay, responses for the earlier one. Okay, you will send the original response only for the duplicate request. Now principal or architect, what he will be saying, persist idempotency key in a distributed store with the expiration policies. Okay, ensure every payment operation remains safe during retries, failover, and client timeouts. Let's say some payment operation is failing, okay, because of client timeout or retries or failover. Okay, so you should ensure every payment operation remains safe. Okay, follow-up question 2 is related to distributed transaction. So software engineer will say that avoid two-phase commit wherever possible. Now what is the meaning of two-phase commit? Why we need to avoid it? Okay, so we avoid two-phase commit in a payment system because every service has to wait for all other before completing the transaction. Okay, so two-phase okay, if one service is slow or crashes, the entire payment can get stuck, reducing availability, scalability. Instead, payment systems use local database transaction, publish event, outbox pattern, and handle failure with retries, compensating actions like saga pattern. Okay, if anything is failing, so refund, so just raise the compensation action. Okay, and then this keeps the payment system fast and highly available. Okay, so what he wanted to say that, let's say you have a two-phase commit. Okay, first you have sent the request, then you will get the acknowledgement, but while these things is happening, other services has to wait, and this should not happen. So you need to use or if any service crashes, so entire system will shut down, right? So in that case, payment system should use local database transaction. Okay, so just store the value in local database. Okay, and then later we will sync it. So now local database transaction means save the payment successfully in your own database first, and publish event, okay, or which is called outbox pattern also. After saving, send an event like payment successful, so other services, order, inventory, email know what happened. Okay, email will send the email, inventory service will decrease the units, right, from the warehouse. And then retries, what it will do, if another service is temporarily down, keep trying until it succeeds. Then compensating action, what is compensating action? It is the saga pattern you will be using here. If a later service step failed permanently, that is inventory unavailable, so perform the opposite action such as refund the payment. Okay, now senior software engineer, what he will be saying, that use eventual consistency with events. Okay, so with events, so you can use eventual consistency, but for transaction related thing you have to be use their strong consistency. Principal architect will say use saga pattern instead of distributed transaction because it is scale better and avoids global locks. Okay, so we will go with the saga pattern here. Now follow-up question 3 is saga pattern. What is saga pattern? So a software engineer will say that in saga pattern each service commits its own transaction, and if a later step fails, okay, the system compensate by undoing the previous business action, that is issuing a refund. Okay, so senior software engineer, his example will be something like this: payment will go to reserve inventory, then after that create shipment, and then send notification. Okay, so it means that if one step fails, compensating action roll back previous successful steps. Principal or architect will say that use orchestration for payment workflows where business rules are complex and choreography for simpler event driven interaction. Now follow-up question 4 is related to CQRS. CQRS is command query responsible segregation. Okay, this is the one of the important microservice design pattern. CQRS, Saga, all these things. Okay, so CQRS, software engineer will say that separate read and write operation. Okay, in CQRS, command query responsibility segregation. We are segregating here responsibility for read and write. You will have two different operations. Okay, and then senior software engineer will say that write update the payment state and read query optimized projections. Now what is optimized projection? So optimized projection simply means a separate read-only view of the data that is designed for the fast query. Okay, view basically you have created. Now principal or architect will say about CQRS is use CQRS only for services with high read and write asymmetric such as payment history and reporting. Okay, so for payment history and reporting you can use CQRS there. Now follow-up question 5th is the last one, is PCI compliant. What is PCI compliant? Compliance. So software engineer will say that never store raw credit card number into the system. Senior software engineer will say that use encryption, tokenization and TLS. Okay, if you wanted to store, then use encryption, tokenization and TLS. Principal software engineer will say that maintain PCI-DSS compliance through tokenization. Okay, and then HSM backed key management. Now what is HSM backed key management? We'll see that. Okay, strict role based access control and network segmentation, audit logging, periodic security assessments. Now what is HSM backed key management? Means that encryption keys are stored and used inside an HSM. HSM is hardware security module. Okay, so you will store your encrypted keys there instead of being stored in the application code or the database. Now you will think that it means that GitHub secrets or HashiCorp vault is similar to HSM, right? No, they are different. So in GitHub secret you use the secret storage for CI/CD, right? Let's say HashiCorp vault you store enterprise secret manager. This is your enterprise secret manager. So all the company information you will store here. Now HSM is hardware device that securely store and use cryptographic keys. Okay. Follow-up question 5th is disaster recovery. Okay, that one was the last second. Now disaster recovery. So software engineer will say that how you will recover from the disaster. So just maintain the backups, right? Senior software engineer will say that cross-region replication and automated failover. Okay, it means that store your data in different region also. So if this region fails, automatically it will request will redirect to different regions. So that is called automated failovers. Now principal architect will say that define clear recovery objectives. Okay, so you can use RPO and RTO for that. RPO is your recovery point objectives, means how much data loss is acceptable after a disaster. Okay, so RPO should be near to zero, means near to zero for payment record means almost no payment data should be lost. If a server crashes, every successful payment should still be recoverable. Okay, now what is RTO? RTO is recovery time objective. It means that how quickly the system should be restored after a failure. Okay, so this is the how much data loss is accepted, and then this one is how quickly system will be restored. So now RTO should be minutes rather than hours. Okay, means the payment system should be back online within few minutes, not several hours. So conduct regular disaster recovery exercises also. Okay, so that's it. Thank you.